Okay guys, so today we're going to talk about significant figures. You should be able to correctly identify how many significant figures are in certain numbers. So I'm just going to kind of walk through the lesson, and we're going to take some notes here in a second for you to follow along with. All right, so today one of the concepts is precision versus accuracy. So if you look at these targets, you can see this one has precision but no accuracy. So precision means it's all in one spot, but it's not exactly right. The next one has precision, has no precision, but has accuracy. So we're kind of in the middle towards the target, but we're not in the same spot. Okay. This one has no precision and no accuracy. So you can see they're kind of all over the place. But this is what we would really want: precision and accuracy. So always hitting the right target every time. And that is the difference between precision and accuracy. But for chemistry, why that makes a difference is right here. We know the precision of numbers by how many places after the decimal point that we can measure. So if we have 75 places after a decimal point, we know for sure what that number is. If we have no decimal point, then there could be rounding errors involved. So that is what makes the difference in the numbers, is how much rounding happened to that number. The big deal on this picture is accuracy is not dependent on precision, and precision is not dependent on accuracy. So as we saw up here, you could have a lot of precision and no accuracy. Like someone might have precision grades. They're all C minus. Not exactly what you want, but if they're all the same, then they're precision. You could have accurate grades, A minus, B plus, pretty good, but not exactly all the same. But what we really want is precision and accuracy, always an A all the time. And that's the same with the number, is we want it to know exactly how much information we have from that number every time. So we want our instruments to be measuring the same every time we measure with them. And that's where this comes into play for chemistry. So today we're going to have these three rules are very important. So we're going to zoom in on these rules so that you can see them really well. Non-zero digits are always significant. Any zeros between two significant digits are significant. And a final zero or trailing zeros in the decimal portion only are significant. So I'm going to pause the video for just a second. I want you to write down these rules in your notebook. Write them down, because that gives you that physical writing it down. You can see it. You'll have it in your notes. You'll have it to look at later on. So I'm going to pause the video for a second, write them down, and then we'll come right back. Okay, so I wrote down the rules in my notebook, and now we are going to go to that notebook, and we're going to do some of these examples together. We'll do some of these examples together so that you can see my reasoning and hear my thinking as we do these examples. All right. So let's look at the first example. The first example says 3.0800, and we want to know how many significant figures there are, or sig figs. So if we look at this, the first rule, we're always going to go back to our first rules. Non-zero digits are always significant. Okay, so the 3 and the 8. Any zeros between two significant digits are always significant. So this 0 is between, and then final or trailing zeros in the decimal part only. So this is a final 0, and there's my decimal point. So my decimal point, trailing 0, this one counts. And then this 0 is significant because it's between this 8 and this trailing 0 in the decimal part. That is significant. So I have 5 significant digits in this number. All right, let's do another one. Number 2 is 0.00418. So we're going to go back to our rules again. Non-zero digits are always significant. So the 4, the 1, and the 8. Next rule, any zeros between two significant, well, there's nothing in between. Final or trailing zeros in the decimal part only. There's no trailing zeros. Here's my decimal point. There's no trailing zeros. These are leading zeros, so they don't count. They're just space holders to tell me about my number. So I only have 3 significant figures in that number. All right, let's look at another one. This third one is a scientific notation number, 7.09 times 10 to the 5th. For scientific notation numbers, you just have to look at the first factor and say the first factor here is 7.09. So we go back to our rules. Non-zero digits are always significant. 7, 9. Any zeros between two non-zero digits or between two significant numbers are significant. So, and then final or trailing zeros in the decimal part. Well, here's my decimal point. I don't have any trailing zeros, so I only have 3 significant digits. All right, let's do a couple more just so we can have some good practice. Or 4, here's one, 91,600. All right, so we always go back to our rules. Non-zero digits are always significant. So the 9, the 1, the 6. Any zeros between? Well, there's nothing between my significant digits here. And then it says final or trailing zeros in the decimal part only. Well, we have a final 0, but it is not in the decimal part. There's no decimal in this number that we have. So those 2 zeros are not significant. So once again, we have 3 significant digits there. All right, and the examples on the list, I'm going to go ahead down and skip to number 10. I know that's weird, but we're going to look at number 10, and number 10 says 0.00800, and I want to go through the rules. So non-zero digits are always significant. The 8, I don't have anything between because there's only one non-zero digit. So the last one, though, final or trailing zeros in the decimal part only. So here's my decimal point. That's a final 0, so that is significant. But now I go back to number 2. Any zeros between 2 significant digits are significant. So that 0 is significant. These are leading zeros, so they are not significant. So we have 3 significant digits in that. All right. For today, you guys are going to go back to the lesson and you're going to pick one of these things. They're all pretty good. This one, the Kuya, has a mistake in it. So there's one problem that you will get right and it will tell you it's wrong, but I know that. So when I look at it, I will understand and grade it appropriately. But then after you're done, please remember to go to scientific notation and significant figures. That is going to help you a lot for the test that'll be coming up next week. I want you to be prepared.